Hello my viewers, you are welcome to this channel, and in this lesson we're going to look at organic chemistry. What do you really think is organic chemistry? Well, simply put, organic chemistry is the study of carbon compounds, excluding oxides of carbon, carbonates, and dicarbides. What does this definition mean? It simply means that, yes, organic chemistry is the study of carbon compounds, but not all compounds of carbon are organic in nature. Take for instance, carbon 4 oxide is a carbon compound, but it is not organic. Calcium trioxocarbonate 4 is a carbon compound. Again, it is not organic. Now, when you remove oxides of carbon, trioxocarbonate 4 and dicarbide from carbon compounds, the remaining world of carbon compounds are organic in nature. So therefore, organic chemistry is the study of carbon compounds, excluding oxides of carbon, carbonates, and dicarbides. We have two main types of organic compounds. The first one is hydrocarbon, look at it here, and the second one is non-hydrocarbon. Hydrocarbon, as the name implies, are organic compounds consisting of hydrogen and carbon only. So when hydrogen and carbon combines, then that compound is called hydrocarbon. We also have non-hydrocarbon. These are organic compounds that have more than two elements. Sometimes you have oxygen added to the hydrocarbon, and that makes it to be non-hydrocarbon. What are the terms used in organic chemistry? There are beautiful terms, terminology that are used in organic chemistry. For instance, we have hybridization, catenation, homologous series, functional group, isomerism, saturated and unsaturated hydrocarbons. We have substitution reaction, we have addition reaction, and we even have alkyl group. These are the terms used in organic chemistry. We're going to be looking at them as time goes by in this channel. First, what do we mean by saturated hydrocarbon? When we say a hydrocarbon is saturated, what exactly do we mean? Well, a saturated hydrocarbon is a hydrocarbon that has single bond separating the carbon atoms. We're going to say that subsequently in this video. So we will say substitution reaction as well, we see addition reaction, we will see alkyl group. Of course, we have already defined what hydrocarbons are. They are organic compounds consisting of hydrogen and carbon only. Then, when we also say a hydrocarbon is saturated, it means that that hydrocarbon has single covalent bond. That hydrocarbon has single covalent bond separating the carbon hydrogen atoms. So that single bond makes the hydrocarbon saturated. A hydrocarbon, therefore, is said to be unsaturated if we have double or triple bond separating the carbon atom. Yes, so when we have double or triple bond, triple covalent bonds between the carbon atoms, we call that unsaturated hydrocarbon. So take note of the difference. A single bond makes saturated, double or triple bond give rise to unsaturated hydrocarbons. Yeah, this is the symbol for single bond. You have the single covalent bond, and this represents double bond, and this is, of course, the triple bond. Another beautiful term we need to consider is what is called alkyl group. What are alkyl groups? Alkyl groups are formed from saturated hydrocarbon when they lose hydrogen atoms. So if a saturated hydrocarbon loses a hydrogen atom, it becomes an alkyl group. And these alkyl groups are usually represented by R. The alkyl groups are usually represented by R, uppercase R to be very specific. For example, look at this simple compound, CH4. This compound has both molecular and structural formula. This is the molecular formula, CH4, and this is the structure. Now, this compound is called methane. Let's assume this methane loses this hydrogen atom. Then, it will now look like this. This space where the hydrogen was occupied is now vacant. So, a bond is here now, meaning that this CH3 can attach itself as a substituent. So this CH3 formed from methane when it loses one hydrogen atom is called a methyl group. So methyl group are usually substituent. They can replace hydrogen from saturated hydrocarbons. Very good. So the next term we need to consider is actually very sensitive and important, and that happens to be hybridization. Hybridization is a very key area that we cannot quickly neglect. It goes hand in hand with the covalent nature of organic compounds. However, we're going to look at hybridization now. What exactly is hybridization? Hybridization is the blending of two different orbitals to form new ones. So when two orbitals of different energy blend, we call that hybridization. And of course, we recall that some of the orbitals we have are the s orbital, the p orbital, and the d orbitals. So when two of these orbitals mix or blend, we call that hybridization. Hybridization is very, very popular in organic chemistry. So it's very good we see it as early as possible. Now look at the structure of hybridization. Remember, we are dealing with organic chemistry, which we said earlier is the study of carbon compound, meaning the central atom in organic chemistry is carbon. Now, this carbon, you can use the SPDF to look at the structure. If you draw the electronic or write the electronic configuration of carbon using the SPDF, you are going to have 1s2, 2s2, and 2p2. This 2p orbital is the valence orbital. So if you draw the structure of the 2s and 2p orbitals, you're going to have something like this. This is the 2s with its 2 electrons. You remember from Pauli's exclusive principle, 2 electrons cannot have the same orientation. Their spin must be in the opposite direction, which means if one electron is facing upwards, the other one must come down. Then this 2p orbital with its 2 electrons are these orbitals you have here. This first orbital is the ps, this is the py, and of course a vacant pz orbital. This is the structure of a carbon atom before hybridization. Now what happens after the hybridization? It will be observed that the 2s and the 2p orbitals blend. In other words, look at the blending. And that blending gave rise to the fact that one of these 2s electrons will be promoted to the vacant 2p orbital. That means one of these electrons will be promoted to the vacant p orbital. The energy required for this electron to enter the vacant orbital is less than what it will need to enter these other orbitals already having single electrons. So this electron will choose to enter the vacant orbital because it requires the least energy. Now, when this electron is promoted to the vacant p orbital, which specifically the pz, then we will have this structure. The 2s electron, now we have 1, will be 1. Then the 2p, we now have the 3 electrons. So we now have a combination or a blending of the 2s and the 2p. This blending of the 2s and the 2p gave rise to the hybridization. So in the carbon atom, we can have 2s and 2p. These two orbitals, they will blend. And when they blend, as you can see, the s orbital will have only 1 electron, the p orbital will have 3 electrons. These 3 electrons are what you are seeing here. This type of hybridization is called 2s1 2p3, or simply put, sp3 hybridization. This is the simplest form of hybridization in organic chemistry. So as we go on, we're going to see the other forms of hybridization, which of course is the sp2 and the sp hybridization. Now, the example we cited earlier, which is methane, the 4 hydrogen atoms can now share its electron with each of these single electrons in the 2s and the 2p orbitals. So when that sharing, we will have a saturated hydrocarbon, which is represented by sp3 hybridization. We will also remember some of the people, the pioneers that have done so much on the hybridization and writing the electronics configuration of elements. For instance, Hund's rule is very popular, and that rule shows that electrons are shared into the orbital singly first before pairing. So when you are distributing electrons into the orbitals, share singly first before pairing. Then we also have the Pauli's exclusive principle, or popularly called the Pauli's principle. What does that principle say? 2 electrons cannot have the same spin or orientation. Even if the 2 electrons have the same principal quantum number, the subsidiary quantum number, and the magnetic, the spin or the orientation or the direction or where the electrons are facing must be opposite, which means that if one electron is facing upward, then the other electron in the same orbital must be facing downwards. This is what is actually represented in this electronic configuration of carbon. Now you can see that in this orbital, the 2s orbital, one electron is facing up, the other is facing down. We actually obey Pauli's principle in writing this electronics configuration. Yes, thank you very much. This is the much we can take for organic chemistry because we're just starting. If this video is found interesting, if it has become very interesting and you like it, then do us the honor, subscribe to this channel, drop a comment, let me hear your feedback, let me read any comments you have from you. Then you can even share the video to your friends so that they too can benefit from this video. Once again, thank you very much, our returning viewers, for subscribing to this channel. And if you are viewing this video for the first time, do us the honor and the privilege, subscribe, share this video, give us a thumbs up. Then we will all help in growing this channel for our own benefit. Thank you very much, and see you in my next video.